Hello students, welcome to Narang PU College online classes. So in the last video we have discussed about the NEET and AMPET bits. So up to 14 questions we have completed, and the next question is question number 15. Question number 15. Which is correct statement for the given acids? The first one. Phosphonic acid is diprotic acid, while phosphonic acid is monoprotic acid. Clear? In the last class I mentioned here phosphonic and phosphonic acid. Clear? Phosphonic acid means phosphonic acid. This is means phosphite H3PO2 hypophosphorus acid. H3PO2 hypophosphorus acid, that called as a phosphonic acid. Phosphonic acid means phosphorus acid. Phosphonic acid means H3PO3 phosphorus acid. This is clear. Now they are asking what it is, and you have to write here monoprotic and diprotic. Monoprotic means the OH means there will be only one OH group. Clear? So you have to write the structure. First of all, you know that first one I will write here the structure. Oxoacids means first one you have to write. There should be one double bond O and there will be one OH. Clear? Then how many hydrogens are there here? Two hydrogens are. This is which one? Monoprotic. It can be only one hydrogen. These are not protic hydrogens because the hydrogen should be attached to highly electronegative atom. That is only protic hydrogen. Clear? So that can only give the H plus. So it is a monoprotic. It is what it is, monoprotic. If you write this one and it is double bond O and there will be one OH group, and next one is what it is there. Three hydrogens are there and one oxygen is left, and OH. And what it is? It is a which one? Diprotic. It is a diprotic. That is the answer. So you see now what is that? First one is phosphonic acid is diprotic while phosphonic acid is monoprotic. Reverse they have given. Clear? Second one, phosphonic acid is monoprotic while phosphonic acid is a diprotic. This is the correct one. So option 2 is the correct one. So next one. Question number 16. The product obtained as a result of reaction of nitrogen and calcium carbide. This I have already mentioned. Calcium carbide plus nitrogen. What you got now here? You will get the compound is CaCN2 plus what is not here? Coke. This mixture I mentioned here, nitroleum. Clear? So this is act as the mix used as a fertilizers, and this is CaCN2 is called as a calcium cyanamide. What it is here? Calcium cyanamide. Nitroleum. Clear? So this is, and so what your answer is here? Option 3 is the correct one, and this is about the competitive of which group one here? 15th group. Clear? So next one we have to discuss about the 16th group, 17th and 18th. So for that, and open here volume 5. Clear? So in this one, page number 19. Clear? Page number 19. Synopsis also given. Once you go through the synopsis and try to do these questions also. Clear? So next one you see. So this is about the 15th group competitive. Now here they have given 16th, 17th and 18th group combined. Clear? The first one. Hypo is used in photography because of its. Clear? In the photography means what they will do when they do the when they take the photo, and our image will be stored in one photographic plate which is actually coated with silver chloride or silver bromide. or silver nitrate also sometimes. Clear? No? So what you have to do, and after that you have to remove that excess amount of the silver bromide or silver chloride, and then our image will be appear clearly. Clear? So for that one, what we will do, we will dip that one into the hypo solution. Hypo means sodium thiosulfide. Clear? So what is the hypo here? Hypo is actually Na2S2, what it is now O3 and 5H2O. This is actually hypo. Clear? Here we will not like here 5H2O, directly we will write. Clear? This is hypo. Hypo means what is what? Into means how many water molecule will be there? 5 water molecule. If you heat, that it will be released. And hypo, and why it is means they have given. One is because of reducing behavior, oxidizing behavior, complex forming behavior, reaction with light. Simple. You have to remove the AZBR. And if you remove that AZBR, it will form a one complex compounds with the sodium thiosulfide. Clear? So what is that one here? And you will get the compound. Take here 2 moles here. Then Na3Az, S2O3 taken. This is the complex, and plus 2 moles of NaBr. Clear? Sorry, 1 mole of NaBr, because there's 4 sodiums are there, and here 3 and here 1. So this is soluble. Clear? Soluble complex. This is what it is not here, soluble complex. So that's why it is used, hypo is used to remove the, what it is here, silver bromide, and it forms which one here, soluble complex. Clear? No? So that is clear. No? Next one, second question. So this is question number 1 and second question. Hydrolysis of 1 mole pyrosulfuric acid produces. Pyrosulfuric acid means what we will call now? Volume. What is the formula? H2S2O7. And do the hydrolysis. Then they are asking pyrosulfuric acid hydrolysis, what you will get. Clear? So what you will get, you see? Just here H4S2O8 means what it is? 2 moles of H2SO4. In contact process we have studied this one. So we will get volume will dissolve into the water, then we will get the sulfuric acid. It is a last step in the contact process. So what you are getting here? 2 moles of sulfuric acid. So option 1 is the correct one. Clear? Third one. Question number 3. Hypo is used in photography too. Just now only I mentioned. Remove the undecomposed silver bromide. To remove the which one? Silver bromide. As a which one? Soluble complex. It removes the hypo. This is what is hypo. Hypo, it removes the AZBR and into a soluble complex. So that's why we will use the hypo. Option 3 is the answer. Clear? So this is next question 4. It is possible to obtain oxygen from air by fractional distillation because of. Clear? So fractional distillation means I already mentioned the very commercial method for the preparation of oxygen is from atmosphere. Clear? So what they will do, and they liquefy the air. So that's why air contains mainly, major constituents in the air is one is oxygen and another one is the nitrogen. And collect the air and liquefy, you will get the liquid nitrogen mainly, and remove just carbon dioxide, small gases will be there, and you just remove those gases like carbon dioxide and SO2, and after then you liquefy and you will get majority of nitrogen and oxygen. After then you have to do the fractional distillation. If you do the fractional distillation, you know that I already mentioned nitrogen is having low boiling point than the oxygen. So that's why first one, which one will be distill out first, nitrogen distill out first, and after then we can collect the oxygen that we have already discussed. So that's why which one is having higher boiling point and which one is having lower boiling point. Nitrogen is having lower boiling point. I already just mentioned boiling point of nitrogen is 77 Kelvin and boiling point of oxygen is 90 Kelvin. Clear? So that's why what should be your answer here? Option 3 is correct one. Oxygen has a higher boiling point than the nitrogen. Clear? Next one. Question number, your answer is here option 3. Question number 5. Oxygen does not react readily with. Clear? Remember, and here we have phosphorus, sodium, sulfur, and chlorine. Clear? So we know that here mainly means oxygen will react with all the compounds. See, phosphorus it is there, phosphorus pentoxide is there, phosphorus trioxide is there, sodium oxide is there, sulfur oxide is there, chlorine oxide is also there. But chlorine does not react directly with the like carbon, noble gases, and oxygen and nitrogen. Chlorine it directly won't react. We have to supply. But if phosphorus is there, phosphorus highly reactive with the oxygen, and also sulfur easily react with the oxygen. It will give the sulfur dioxide. This means if you take the sodium, phosphorus, sulfur easily react with the oxygen. But chlorine it won't react easily. It will react, but some drastic conditions are required. So that's why chlorine will not react directly with what it is here, carbon and noble gases, and the third one is here nitrogen and oxygen. Clear? Next one. Clear? So next one is question number 6. If you see the question number 6, this is one of the important question. Remember? So the gases respectively absorbed by the alkaline pyrogalal. Remember, alkaline pyrogalal and oil of cinnamon. Clear? So here pyrogalal means we have discussed in the alcohol, phenols and ethers. In the phenol we have discussed what is the pyrogalal, OH and OH, and here what it is not OH. Okay, so this is what we will call here pyrogalal. This is what it is not here, pyrogalal. Okay, so pyrogalal it is absorbs the oxygen. It absorbs the what it is not here, oxygen, and it absorbs the oxygen and it oxidizes alcohol to ketogroups. Clear? So simple. So what happened here is hydrogen are there, hydrogen, and this bond it will come here. It will become a double bond, and here double bond means this double bond will come here, and this hydrogen will move here. Clear? Then what the compound you will get? You see, this is compound. OH will be there here, and double bond, there will be a double bond, and there will be a double bond. And here, how many hydrogens are removed here? H2 will be removed, and here what is there? O2 is there. So what you will get? H2. So this is the reaction. So this we will call as orthoquinone. Clear here? So this is, so that's a pyrogalal absorbs the which one? Oxygen. Clear? Next one. Next one is here oil of cinnamon. Oil of cinnamon, it contains many compounds, mainly cinnamaldehyde, cinnamic acid. Means it will have the double bond compound. Cinnamaldehyde means this is, clear? So this is CH double bond, CH, CHO. This is cinnamaldehyde. What we will call this is cinnamaldehyde. Clear? So these are mainly cinnamaldehyde, cinnamic acid also. Cinnamic acid. These are the main constituents in the Vermahia and cinnamic acid. They are main constants in the cinnamol. Yeah? So that's why. What happened here? There is a double bond. If double bond is there, so which one absorbed here? Ozone. Ozone is because double bond is there. One oxygen and one oxygen. You have to break the double bond and put the oxygens here. We have already discussed. Clear? When double bond is there and ozone will react with the double bonded carbon, means unsaturation, with the unsaturation. So that's why cinnamon absorbs the ozone and pyrogalal absorbs the oxygen. So that is your answer. So what is your answer now? Your option should be option 2 is the correct one. Clear? Option 2 is correct one. This is about question number 6. Next one. Question number 7. The chemical used for cooling in refrigeration is, I already mentioned, liquid ammonia is used as a refrigerant. So that's why your option 4 is the correct one. Right? Questions these are in the uses they have given. Clear? So when concentrate H2SO4 comes in contact with the sugar, come in contact with sugar, it becomes a black. It becomes what it is, my here? Black. Then they are asking, so this is due to, this is what it is, ma? Due to. See what is that one? Sugar, you know, what is the sugar? Sucrose. What is the formula of sucrose, ma here? Sucrose formula C12, H22O11. When it is reacted with concentrate H2SO4, this is, you know that concentrate H2SO4 is act as a powerful dehydrating agent. This is very important question I mentioned in the previous examination, also important. It is, you know, dehydrating agent. Dehydrating agent means what we will remove? Water it will remove. Shall I write this one? C12 H2O 11 times here. Same C12 11 into 2 22 and here O11. So then what it is, ma? Concentrate H2SO4. You know that concentrate H2SO4 is powerful dehydrating agent. It removes what it is, ma? Water. It removes the water means you will get 12 carbons and 11 H2O. Clear? So what is your answer now? And you will get here, yeah, this is black, you know, compound, it is black, you will get the carbon. Carbon means in the, which color? Black in color. So that's why this is due to which one they are asking? Hydrolysis, hydration, decarbonization, dehydration. Removal of water, what we will call? Dehydration. Clear, ma? Dehydration. So what is your option here? Option 4 is the correct one. Next one. Coming to the question number 9. Which shows maximum catenation property? Which shows maximum catenation property? In the 16th group elements they are asking which one shows maximum catenation property? Oxygen, sulfur, selenium and tellurium. I already mentioned here catenation property. Clear? So catenation property means what it is? Self-linking by the atoms. Self-linking of atoms. Clear? So if you take oxygen, here like oxygen, self-linking of oxygen. Clear? So in this case, you know that oxygen is a small atom, and so that's why. And here small atoms means the bond length is short, so that's why there will be a repulsion, maximum repulsions among the, you know, lone pair of electrons. To avoid that, and oxygens will move far away from each other, so that's why bond length increases, and bond length increases, bond strength decreases. So that's why if bond strength increases, you know, and it will show the very low catenation property. Clear? So that's why which one will move from the, means which one will show the maximum catenation property means among this sulfur. Sulfur actually, you know, oxygen should form means it should show the high maximum catenation property, but due to the maximum lone pair repulsions are more in the oxygen, so that's why sulfur, next atom which one was sulfur. Sulfur will show the maximum catenation property. If you go down, oxygen to mean sulfur to selenium and tellurium, their size increases. When size increases, bond length also increases, so they cannot link together by a number of selenium or tellurium atoms. So that's why catenation property maximum for which one here? Yeah. Next one. Which of the following bond has highest energy? Just now only I mentioned. See one here. Actually, this oxygen is there. Highest energy means so single bonds they have given sulfur, oxygen, sulfur, and selenium, and tellurium, Clear? You know that oxygen and oxygen both are small atoms, so that's why overlapping will be very strong. So that's why bond is very strong here. Bond is strong means, you know, these atoms are very close to each other. Clear? This is oxygen and this is oxygen. Due to the strong overlapping, they come very close to each other. When they come very close to each other, and their lone pair repulsions will be maximum. When lone pair repulsions maximum, to avoid that, both the oxygens will move away from each other. Then automatically bond length increases, then bond strength decreases. So that's why in this case, actually it should have maximum bond dissociation enthalpy, but which one will have here? Sulfur. Why? Because sulfur is a, you know, somewhat bigger, so that's why. And bond length somewhat, you know, large, so that's why repulsions will be minimum here. Lone pair repulsions will be what, you know, somewhat minimum compared to the oxygen. Okay? But if you are going selenium, These here sizes increases, bond length increases, so that's why automatically bond strength decreases. So which one will have the highest or maximum bond dissociation energy means sulfur will have. I already discussed the same thing in the BU class also. Clear? So this is about question number 10. Clear? Next one. The geometry of H2S and its dipole moment are. Geometry of H2S. Clear? So what is the geometry of H2S here? So simple. I will say one small trick to to calculate the or to find out the geometry. Clear? So that is you already know. So H2S they have given H2S. Clear? H2S means what is the central atom here? Sulfur. Sulfur belongs to which group? Sulfur belongs to 6th group. 6th group means right here 6 electrons. How many electrons you have to write now? 6 electrons. Clear? Now sulfur is forming how many bonds here? 2 bonds. One hydrogen and another hydrogen. Means hydrogen sulfur to make a one bond with hydrogen. Sulfur should use one electron to make a one bond with the hydrogen and another electron to the another hydrogen. Clear? So how many bonds are here? 2 bonds, and remaining what are those, and we will consider those as a lone pairs. Clear? So how many bond pairs? Sigma bonds here, sigma bonds only we will consider as a bond pairs. How many bond pairs here? 2 bond pairs. How many lone pairs here? This is pairs. This is one lone pair and this is one lone pair. So 2 lone pair. So 2 plus 2 means total how much? 4. 4 means what is the hybridization? Sp3. When it is Sp3 hybridization, 2 bond pairs and 2 lone pairs, angular structure are what it is man? Bent structure. Angular shape are what it is man here? Bent shape. So what is the shape of here? H2S means H and here angular, there will be a 2 lone pair of electrons. So that's why angular shape, and is it having 0 dipole moment? No, it won't have 0 dipole moment. So that's why, and first option is the correct. Next question number 12. See one question number 12. What is the question number 12 here? The formula of ozone is O3. It is a allotropy of oxygen, compound of oxygen, isotope of oxygen, none of the above. Clear ma? So ozone is what it is ma? Ozone is a allotropy form of which one? Oxygen. Another form of oxygen, that is. Clear ma? O3. Clear? Next one. The number of 13th question. Option 1 is the correct one here. So next one is 13th question. The number of pi bonds in sulfuric acid molecule. Sulfuric acid formula, what is the sulfuric acid ma? H2SO4 is the sulfuric acid, and you have to, that's why you see, if you know the structure then you can easily write. So you have to practice. Clear? Simple. What is the central atom here? Sulfur. What is, you know that whenever it is oxo acid, you already know oxo acid. So simply there should be a double bond O and OH. Clear? Next, how many hydrogens used here? One hydrogen left, 2 oxygens left, another one hydrogen and oxygen I will write as a OH. One oxygen is left means you have to put that one with the double bond. When OH is there, single bond. Only O is there, double bond. This is the sulfuric acid formula. So how many pi bonds are there here? 1 and here 2. How many pi bonds are there here? 2 pi bonds. So that's why your option should be option 3 is the correct one. Clear? Next one. 14th question, same repeated question. When concentrated H2SO4 comes in contact with sugar, it becomes black. Due to what reason? Just now only we have discussed concentrated sulfuric acid act as a powerful dehydrating agent. So dehydration. Ozone is not an allotrope. It is an allotrope and powerful oxidizing agent. I already said ozone is the very powerful oxidizing agent. Only next to fluorine. After fluorine, which one is the powerful oxidizing agent here? Ozone. So it is also correct. It is a paramagnetic. No. Oxygen is a paramagnetic and ozone is a diamagnetic. So that's why. And it is a bent molecule. Bent molecule means ozone structure. You already know. What is the ozone structure? This is the ozone structure. It is a which molecule? It is a bent molecule. So which one is not correct among these? It is a paramagnetic, is not a correct, it is a diamagnetic. Clear ma? Good. Next one. Coming to the question number. What is answer 15th question? 15th question answer is what is one here? 3. Next, coming to the 16th one. The oxidation state of most electronegative elements in product of reaction of barium oxide with sulfuric acid. Barium oxide. What is the formula of barium peroxide? Not oxide it is. Barium peroxide, BaO2. Why? Because barium belongs to which group? Second group, it should be a +2. +2 means it should be a -2. -2 means what is the oxidation state of oxygen? Should be -1. When in which cases oxygen exhibits the -1 oxidation state? In peroxides. So that's why it is a barium peroxide. You don't think that it is a barium oxide. Clear? No, barium belongs to second group. Second group means its oxidation state should be valence should be 2. So it is a +2 means it should be a -2. -2 means here oxygen 2 molecules are there. It should show the -1 oxidation state. So barium peroxide when reacted with the H2SO4, what you will get? You will get the compound here is barium sulfate plus hydrogen peroxide. Barium sulfate plus what it is? Hydrogen peroxide. What they are asking here? They are asking most electronegative element oxidation states in the products. Here what is the most electronegative element? Oxygen. Here also oxygen. What is the oxidation state of oxygen here in the sulfates? -2. But here oxidation state in the peroxides -1. That is what it means. There will be a -1 and -2 should be the answer. So option 2 is the correct one. Clear? Next one. Question number 17. Which compound act as a oxidizing as well as reducing agent? Clear? So I already mentioned intermediate oxidation states are there and they act as a both oxidizing and reducing agent. If any element is in its highest oxidation state in their compounds, they only act as a oxidizing agent, cannot act as a reducing agent. That I already mentioned. Now you see. First one, option. Sulfur dioxide. Sulfur dioxide. What is the oxidation state now? +4. And Mn2O7. What is the oxidation state here? +7. Manganese. Clear? Next one. Al2O3. So what is the oxidation state here? +3. And chromium CrO3. What is the oxidation state now? +6. If you see, what is the sulfur maximum oxidation state? Maximum oxidation state of sulfur is 6. Clear, my dear? So that's why. And but here showing what it is, +4 oxidation. Manganese highest oxidation state is +7. Chromium highest oxidation state +6. Aluminum highest oxidation state is +3. So all these three act as a oxidizing agents. Clear? So here it is in +4. +4 means what is the highest oxidation state of the sulfur? +6. So that's why it can undergo oxidation to highest oxidation state. It can undergo means it act as what it is, reducing agent. It can act as what is reducing agent. Clear? And it can also undergo reduction. It can show the -2 and +2 or +4 oxidation states also. Because you know what is the oxidation states of sixth group elements. Oxygen only show the -2 oxidation state. Clear? Sulfur remaining elements they will show the +2, +4 and +6 oxidation state. So that's why it can also undergo reduction. When it undergo reduction, it can act as a oxidizing agent. So that's why what is your mark? So if it is any element in its intermediate oxidation state, means it is in between lowest oxidation state and highest oxidation state, then those type of compounds always act as a both oxidizing and reducing agent. So that's why what is our option here? Option 1 is the correct one. Clear? Next one. Question number 18. Question number 18. Which one of the following is most stable on heat? All we have discussed these are. Clear? On heat. You know that HF, HCl, HBr, HI. So which one is most stable? Most stable means it depends upon the bond strength. Which bond is strong? That is most stable. You know hydrogen and here fluorine. both are same size elements, so that's why overlapping of orbitals will be and strong, so that's why, and bond will be very stable. If it is very strong, bond is strong, and you know this is most stable, so this is the stability atom. But here if you see, this is hydrogen, this is iodine, so that's why overlapping of 1s orbital and you know iodine is 5p orbitals, and it is you know and our overlapping will be not efficient, so bond will be very weak. So that's why your option should be HF. HF is the strong, means having stable bond, means stable to heat. Next one, which of the following is weak acid? Among this, which one is weak acid? Weak acid means what? It has to give the H plus ions very easily. Clear? But here you see, in this case the bond is very strong, but here the bond is very weak. So which bond is weak? And that compound gives the H plus ions very easily. So that's why which one is the strong acid? Hi is the strong acid. So which one is the weak acid? They are asking weak acid. This is the strong acid. Weak acid is which one? HF. This is the acidic order. HCl, HBr and HI. Which one is strong acid among the halogen acids? Hi is the strong acid and HF is the weak acid. Clear? So you have to don't see here electronegativity. You have to see the bond strength. Clear? Next one. So option 3 is the correct one. 20. Question number 20. Chlorine act as a bleaching agent only in presence of. I already mentioned here. Chlorine act as a bleaching agent only in moisture or in aqueous solution. Clear? So why? Because you know that whenever chlorine, it means it acts as a bleaching agent, means it has to provide the oxygens. Clear? So chlorine, whenever it is in react with water in presence of moisture or in aqueous solution, and it gives the nascent oxygen, and this nascent oxygen is the responsible for the oxidizing properties and bleaching properties of chlorine. So that's why, and what it is here, it only act as a oxidizing and bleaching agent in presence of moisture. If dry chlorine, if they mention, cannot act as a oxidizing as well as bleaching agent. So, and moisture chlorine and chlorine in aqueous solution only act as a oxidizing and bleaching agent. So your option should be option 2 is the correct one. 21 question you already know. The outermost electronic configuration of most electronegative element is. What is the most electronegative elements? 17th group elements, means fluorine is the most electronegative element, and fluorine belongs to which group? 17th group. 17th group, what is the general electronic configuration? NS2, NP, 5 plus 2, 7. That is. Next one. Which of the following is a strongest acid? Clear? So 21 is over, and 22. Which one is the following is the strongest acid? They have given HClO4, clear? So HClO3, and another one is H2SO3, and H2SO4. Clear? So they have given here sulfur oxoacids and chlorine oxoacids. Clear? I already mentioned whenever different oxidations means different oxides or oxoacids of the different elements, then you have to see the electronegativity. Clear? And also high oxidation state. And here, and chlorine and sulfur, which one is the most electronegative? Chlorine is most electronegative. So that's why chlorine oxides are, stronger than the what it is more acidic than the sulfur oxo acid. That is okay. Got my point? Here chlorine different. You see here central atom is chlorine. Here central atoms are which one? Here central atoms are sulfur. First of all, you just identify chlorine oxoacids and sulfur oxoacid. Which one is more acidic? Because chlorine is more electronegative than the sulfur, so that's why chlorine oxoacids are more acidic. So that's why compared to these two, these are more acidic. Among between these two, which one is more acidic? Both are what it is chlorine oxoacids only. So that time and oxidation state decides the acidic character. So what is the oxidation state here? +7, And what is the oxidation state here? +5. So which one is more acidic here? And this is more acidic. So among this, and perchloric acid is the most acidic. So your option should be what is not here? Option 22 is 22. Option 22 question. Option 1 is the correct. Next one. Question number 23. Then they are asking the type of hybrid orbitals used by the chlorine atoms in ClO2 minus. Then just now only I mentioned how to do the means how to calculate the hybridization small trick I have mentioned. Which one is the central atom here? Chlorine. Chlorine belongs to which group now? 17th group or 7th group? Because if you don't consider the D block element, you will consider those are which one? 7th group. So that's why chlorine belongs to 7th group. So how many electrons you have to write here? 7 electrons. Right here how many electrons? 7 electrons. 1, 2, 3, 4, 5, 6, 7. Clear? But minus is there. Minus is what is gaining of 1 electron. So total you write 8 electrons here. Actually chlorine belongs to 7th group. So that's why you have to write 7 electrons. So here negative charge is there. So negative charge means 1 electron will be added. So that's why 8 electrons. Oxygen forms, you know how many bonds? Oxygen forms 2 bonds. One is a sigma bond, another one is a pi bond. So that's why oxygen and chlorine to make a bond means chlorine like this oxygen will be formed. Clear? So oxygen forms 2 bonds. So that's why to form a 2 bonds, chlorine should give how many electrons? 2 electrons. To form 1 bond, chlorine should give 1 electron, oxygen should give 1 electron. Then 1 bond will form. What my bond here? Means to form 2 bonds, chlorine should give how many electrons to oxygen? 2 electrons should share. Oxygen will give 2 electrons and chlorine will give 2 electrons. Then 1 bond will form sigma and another 1 bond form pi. So how many oxygens are there here? 2 oxygen. One is sigma and another one is pi. Clear? So that's why 5 bonds we never consider in the hybridization. How many bond pairs are there? Sigma bonds only bond pairs. There are 2 bond pairs. Plus how many lone pairs are there? Remaining only lone pair. How many lone pairs we have? 2 lone pairs. Don't consider here 4 electrons. Remaining always lone pairs. So what it is? 2 bond pairs and 2 lone pairs. Total how many? 4. 4 means what it is? Sp3. This is hybridization is what is Sp3. So your option 1 is the correct one. Next one, 24. Which of the following statement is correct for CSBr3? CSBr3. Cesium. Cesium belongs to which group? First group. First group means what should be the oxidation state here? +1. Clear? So that's why this total 3 bromines should have the oxidation state -1. Got my point? If it is there, you don't think that here 3 into -1 is a -3. Each one will have the 1/3 oxidation state. So that's why here what is the here bromine. Here this bromine will be, you know, this is negative and here CS is positive. This is the bond. Clear? So that's why what is the oxidation state here? How it will be dissociated? It will be dissociated CS plus and Br3 -1. Clear, my dear? So what is your option now? Your option should be option 3 is the correct. 24 is option 3 is correct. Clear? Next one. Go to the 25. Coming to the 25. Then see what it is. Fluorine does not show positive oxidation state due to absence of. You know, fluorine does not have the d orbitals. Clear? That is the answer. Next one. Which one of the following is not a pseudo halides? Clear? Pseudo halides. Clear? What is pseudo halides means? These are the compounds consisting 2 or more than 2 electronegative atoms, of which one must be the nitrogen. Those halides means we will call those compounds we will call it as a pseudo halides. Clear? Right here, what is pseudo halides? The compound what it is here? Which question is it? 26th question. So what it is pseudo halides. Clear? Pseudo halides. Right here, compounds are ions. You can write. This is halides means ions only. Clear? Ions consisting, clear? So consisting of two are more than two or more electronegative atoms. Two or more electronegative atoms. Electronegative atoms of which one should be the one is what is nitrogen. One is what it is here nitrogen. One is nitrogen that has properties similar to halide ions. Properties similar to what is here halide ions. Pseudo means false actually. Clear my halide. So they are not a halides. They are halides means what is one. And your X minus should be there. But in the compounds, in the pseudo halides, halogen won't be present. But they show the similar properties with the halide ions. So we will call those as pseudo halides. But they should consist how many? Two or more electronegative atom. But among those electronegative atom, one must be the nitrogen. So those type of halides, what it is called, we will call pseudo. That those type of compounds we will call pseudo halides. Clear? See the now what is they are asking, which is not a pseudo halide. Now what is the first one here? You see, the first one is, and here CNO minus. Clear? Electronegative atoms are there. One of electronegative atoms should be what is nitrogen present. Second one RCO minus. Here two electronegative atoms are there. Is this ion is having any nitrogen? No. So that's why it is not a pseudo halide. And next one OCl minus. Here how many electronegative atoms are there? Two electronegative atoms are there. One of electronegative atom is which one? Nitrogen. So it is a pseudo nitrogen. And next one N minus. Here you see three electronegative atoms are there. At least one electronegative atom is which one? Nitrogen. So it is also, these three are pseudo halogen, but this is not a pseudo halides. Clear? So your option should be option 2 is the correct one. Next one. Question number 27. What is the 27? Elements of which one of the following group will form anions most readily. Anions most readily. Oxygen, nitrogen, halogen, alkali metals. Anions most readily means which one will form? Halogens. Why? Because they are one electron less to the mobile electronic configuration. So they need one electron. So that's why they immediately accept the electron to form the anion. So that's why halogens will form anions most readily. Or you can say halogens are most electronegative. Clear? So that's why they can easily accept the electron. That is also can be written. So next one. 28 question. Clear? 27, what is the answer? Option 3. 28 question. Clear? So which chlorine is, when chlorine is passed over dry silicate lime at room temperature, the main reaction product is. Clear? So what is here? Whenever calcium hydroxide through this, when we pass the chlorine, then what the compound we will get? Peroxide. See here what you will get here? In this one CaO, Cl2 plus what you will get? H2. So this is calcium hypochlorite. So that is your answer. So C option 3 is the correct. Next one is question number 29. Question number what is 29? Okay, see that. The reaction of sodium thiosulfate with iodine is. So this is sodium thiosulfide, sulfate, Na2, S2O3. Clear? Sodium sulfate means what is the formula? Na2SO4 is the sodium sulfate formula. Sodium thiosulfate. Thio means what? Instead of one oxygen, you have to put the one sulfur. That is only Na2S2O3. Sodium thiosulfate. Clear? That is we will call as a hypo. Na2S2O3, what we will call now? This is hypo. Clear? So whenever it is react with the iodine, what the compound you will get? Clear? You will get the iodine and IO2 iodine molecule and 2 sodium molecule will be formed as a Na. So that's why take here 2 moles here. Then what we will get? Na2S4O6 plus 2 moles of Na. Clear? So sometimes oxidation state. This is sodium tetrathionate. What we will call here? Sodium tetrathionate. Sodium tetrathionate. If you calculate oxidation state here, you will get 2.5. Here oxidation state you will get 2. Sometimes they will ask when iodine reacted with the sodium thiosulfate, and that is hypo, you will get the compound sodium tetrathionate, and in that one what is the sulfur oxidation state? It is what is 2.5. You can calculate, and this is plus 1 and you don't know what it is, let it be x, and oxygen is minus 2. 2 into plus 1 plus 4 into x plus 6 into minus 2. It is a total molecule 0. So 2 plus 4x minus 12 is equal to 0. So 4x minus 10 is equal to 0. So x is equal to 10 by 4. 10 by 4 means how much? 2.5. That is. Okay. Sometimes that question also asks. So it is very important reaction. You have to remember. Okay. So what is your answer now? And sodium tetrathionate. What is the gives? What it gives? Sodium tetrathionate. Yeah. So this is the question number 29. So question number 30. Which one of the following is most basic? Which one is what is most basic? So they have given here I minus, Br minus, and Cl minus, F minus. Among these, which one is most basic? Okay. First you write, and conjugate acids you write for this one. Conjugate acids means what? Add H plus, then what it is become? Hi, and here HBr, and here HCl, and here HF. Clear? You know what is the acidic order for this one? Which one is strong acid? HF is the strong, Hi is the strong acid. You know that conjugated acid base theory. If acid is strong, it conjugated base. Conjugated acid means what you have to add? H plus ion you have to add. Conjugated base means what you have to do? Remove the H plus ion, then I minus will be added. So strong acid is there, its conjugated base is weakest. Strongest acid conjugated base is a weakest. Weakest, you know, acid, its conjugated base is a strongest. Okay? So among this, it is the strongest acid. Its conjugated base is a weakest base. Clear? It is a weakest base, and it is a weak acid. It is weak acid means its conjugated base is a strong. That is the question how to do this. Clear? Now what they are asking in the question? They are asking which one of the following is most basic. Which one is the most basic one? It is a strong base. So that's why it is a most basic. Weak acid it is. It is a weak acid. Its conjugated base is a strong base. Clear? It is a strong base. That is answer. So option 4 is the correct one. Now mark the strongest acid. Just now I mentioned HCl, HBr, HF and HI. Which one is strong acid one? HI is the strong acid. Next one. 32. Which of the following halogen has greatest electron affinity? Electron affinity, electron gain, enthalpy. So which one will have highest? Fluorine or chlorine? I already mentioned very important question. This is chlorine will have the high electron gain enthalpy or high electron affinity than the fluorine, because of fluorine being a small in size. Clear? There will be repulsions among the electrons in a small room, that is small orbitals. So incoming electron it won't allow, because more repulsion will be there if incoming electron enters. So that's why which one will have the highest electron gain enthalpy or electron affinity? Chlorine. So for 32, option 2 is the correct one. 33. Which of the following is strongest oxidizing agent? Which one is strongest oxidizing agent? Fluorine is the strongest oxidizing agent among the halogens. Clear now? Next one. 34. The color of iodine solution is discharged by shaking it with an aqueous solution of. Just now only we have mentioned this is iodine. Clear? So iodine, you know, and iodine, what is the color of iodine? Violet. Violet color here. When it reacts with which one? Hypo, sodium thiosulfate, then it will be converted to NaI. NaI means this color is what it is. Previous this color is violet. When it is reacting with the hypo, the color will be discharged. So that's why sodium thiosulfate. Clear? Chlorine gas is dried over. Chlorine gas is dried over which one? Concentrate sulfuric acid. Clear? Concentrate sulfuric acid, you know, dehydrating agent. It won't react with the easily, you know, chlorine. So that's why it can easily, you know, what it is use it as a, means it can easily remove the water molecule if chlorine has. So concentrated gas over is a dehydrating agent. It can be used as a to remove the water, clear, from the chlorine. Clear? Next one, 36. 36. What is the seaweeds are important source of? Seaweeds are important source of what is iodine. In the occurrence I already mentioned. Iodine means seaweeds are the main source for which one? Iodine. Mark the strongest reducing agent. Strongest reducing agent. What they have given here? HF they have given. In the diamond case they have given H2F2. HF. HCl. This all I have discussed in the classroom. Clear? In the last previous videos I have discussed. They are asking reducing agent, strongest reducing agent. Reducing agent means what it will do? It reduces other substance by providing which one? Hydrogens. All are having here hydrogens. All are reducing agents only. But which one is the strongest reducing agent means which one gives the hydrogen easily to others. That is a strong reducing agent. So which one gives the hydrogens very easily? HI can give the hydrogen very easily. Why? Because here bond is weak. This bond breaks easily. So HI can provide the hydrogens easily to other substances. So anyone is providing hydrogens and those substances act as a power reducing agent. If anyone is providing oxygen, that act as a oxidizing agent. So which one gives the provides the hydrogens easily? HI provides the hydrogen easily. So it is the strongest reducing agent. Then next one. Coming to the question number 38. Clear? The first compound of noble gas prepared by Jan Bartlett was, I already mentioned, xenon hexafluoroplatinate. Clear? So xenon hexafluoroplatinate. This is the first compound prepared by Bartlett. Clear? Xenon hexafluoroplatinate. Clear? That is the answer. So next one is 39. So here Pt, not P, because platinum it is would be there. So xenon hexafluoroplatinate 5 actually. Clear? So that is your compound. Directly they have given. Xenon hexafluoride, that is 6. Xenon hexafluoride on complete hydrolysis. Complete hydrolysis means what you have to do? All fluorine should be removed. To remove all fluorine, how many water molecules you have to use? 3 water molecules, because 6 hydrogens and 6 fluorines will be removed as a 6HF. Then what will be formed? XeO3. Complete hydrolysis and XeF6, you will get the XeO3. I already mentioned XeO3 is a explosive. It is what it is not? Xenon trioxide. It is a explosive. Clear? Next one. And 40. The mixture is used by the sea divers for respiration is off. I already mentioned previous they use it to carry the oxygen cylinder which is mixed with the nitrogen. But nowadays which one they are using? Instead of nitrogen they are using helium. Why? Because helium is very very less soluble in our blood. Clear? So next one. This is the 40th question. What is the answer here? 2.